Hi, in this video we will be talking about XML compressors case study for liquid benchmarks. There are 5 implemented XML compressors in liquid benchmarks: gzip, gzip2, XML ppm, and XWRT. The websites can be reviewed for further information about each algorithm and each implementation. In order to run a benchmark in liquid benchmarks, we have 3 different components. One is tasks, basically decompressing XML documents should be represented like datasets, and also the compression or decompression format. The other is metrics, so the compression ratio, compression time, and decompression time can be extracted from the results. Operating systems. So the services we have implemented on Amazon EC2 VMs, and we have created images. So liquid benchmarks will be using those images or snapshots in order to run the experiments. Some of our services are used based on Windows, and some others are based on Linux or Ubuntu. So now it's the demo time. I will be showing you exactly how to create and run an experiment in liquid benchmarks. So first we need to log into liquid benchmark platform. We need to provide our email address and our password. So it's loading, and it's been loaded. Now we need to, for the first thing, we need to create a new domain. So we will click on this button, plus, we will name it test domain, and the description, if you are willing to put a description, so we can add a description, but it's not mandatory. Hit on save. So we have our test domain added to the system. So let's create a subdomain. As we can see, domain, then subdomain, and then services. So we are now in subdomain level. Right click on your domain and add new subdomain. So now we will call our subdomain XML Compression. Again, the description can be provided, but it's not mandatory. But I'm gonna put in this subdomain compression, decompression will be tested, and hit on save. Now, as we can see, XML compression has been added on the test domain. So open XML compression. We can see we have different components in the system. So we have services schema, sample algorithms, computational environment, and tasks. Under services schema, we have inputs and outputs. So all these components have been added by the system. So we have to provide information for all of them. So let's just start by inputs. Basically, the input parameters will be used by our services. So we have to provide all of the parameters which we need to send to our services. So let's create a new parameter. Right click on inputs and add new parameter. Title, dataset, file, URL. You can provide a description. Type should be URL because it's basically a URL, this parameter, and it is not optional. It can be optional, but this one is mandatory for all of our compression algorithms. Hit on save. So we have dataset file URL. We have another input which is called mode, and it's text. You can add a description, and it is not optional, so I leave it just unticked and save. So we have two inputs. The outputs, basically we define our metrics. So we wanna get time and we want to have some comparison based on time between different algorithms. So I define time and hit on save. So I have time as well. So for sample algorithms, let's define gzip. We can add a description, and the service path for gzip would be this. So this service path is basically the actual path in the virtual machine on the runtime, and the platform needs to be able to connect to this path and send our parameters. So this is the service path. Hit on save. So we have our gzip. Let's add another one. XML PPM, and here is the service path. Well, we have XML PPM, and add another one which is called XML. Here's the service path. And save. So we have 3 sample algorithms for our demo. So in any time, if we make any mistake or we change our mind or anything happens, we can go back and update any of the objects. For example, I can go right click on XML PPM and get properties, and I can update this service path if I made any mistake when I was adding this. So let's go and add a new computational environment. So right click on computational environment and add new computational environment. I'm gonna call it Windows. The description is not mandatory as well. We have basically 2 sizes for our first alpha version. One size is 1 CPU and 600 megabytes of RAM, and the other version is 1 CPU and 1.7 gigabytes of RAM. So I'm going with the first one, the first size. So basically, if the size is bigger, the algorithm will run faster, and the time will be lower, but I'm gonna just use the first one. And the image ID, so the image ID shows our image snapshot of our virtual machine, which we have been created and deployed our web servers on that machine and created the snapshot. So this is the basically Amazon snapshot image ID. So I have to provide this, and hit on save. So we have our Windows computation environment as well. So let's add a new task. So add new task. I'm gonna name it compression task, and description is not mandatory again, and type I'm gonna leave it private. It can be public. If we make it public, so let's provide dataset file URL. So dataset file URL and mode comes automatically from our input parameters. If we didn't define these input parameters, we wouldn't have these two in here when we were defining the new task. So basically, we must define all of our input parameters prior to creating a new task. So the system will automatically read from the inputs and provide them in here. So in this part, we must provide all the values for the parameters. So I put dataset file URL. So this is a dataset file which has been stored on Amazon S3, and the mode I'll just put C, which means compress. So I hit on save, and I have my task. So I just named it compression task. Now let's create a new experiment. So in order to create a new experiment, we need to provide one task, one computation environment, one sample algorithm, and one input parameter, one output parameter, and one output. These are the minimum provided value. So we can add more sample algorithm or more computation environment, so we will have more experiments running on the system. So basically, I'm interested in time, so I put time. It's just easy, drag and drop. So for sample algorithm, I want to run all of the algorithms on the same machine. So I put all of them in the experiment part, and I'm gonna run it on Windows machine, and I'm gonna add compression task. So this is the values for the input parameters. These three are the algorithms, and this is the output parameter, which is time, and this is the machine. This is the actual virtual machine. So let's add it to the queue. So when we are adding to the queue means the experiment will go and stay in the queue and will wait for the Liquid engine from the backend to run our experiment on Amazon machine. So the experiment results can be public or private. If it's public, the other users in the system can see and use our results, and it's the default one. We can change it to private, but I just want to leave it as public. And while we're doing this, the system is checking all of the provided parameters. So basically we can see in here, algorithm is detected, computation environment is detected, task is detected, and everything is detected and okay. So everything is fine, and we just need to hit okay here. And what happens next? Constructing experiments, and it's just constructing all the experiments, possible experiments. So I assume we must have 3 experiments because we want to run 3 different algorithms using the same task on the same machine and one output parameter. So 3 different algorithms. We must have 3 different experiments. So let's check the output in here. So checking algorithm, gzip, adding experiment to the queue. So gzip as an experiment has been added to the queue. This is the you can see lots of information which comes out of the system. So this is the input parameter for gzip, and then XML ppm, it's been added to the queue, and everything has been added to the queue. And in the end, you'll see the ID number in order to track your experiments. So ID number 151, 152, and 153 has been added to the queue. So now let's go and see our experiments in the queue. In order to see the queue, we need to go to previous attempts. So basically when we add it to the queue, it's a kind of previous attempt. It's a previous attempt which is still in the queue, but it will run in the future. So the place to look at the queue is previous attempts. So I click on previous attempts. So we can see we have 3 attempts here: 151, 152, and 153. And the only difference between these 3 is the algorithm. So XML ppm, XML, and gzip. And we can see the status is pending. It will take some time for Liquid benchmark to create virtual machine and run our experiments. So I have to wait and let the system do the job, and I will stop the video and then start it again and explain what exactly happened in the system. I just want to point you out something. If you want to get notifications from Liquid Benchmark, we have 2 ways of getting notifications. You can either check notifications tab in here. So this is basically notifications tab. You can see everything happening in the system exactly. So for example, the last one which has just happened is creating a virtual machine. So the system is creating a new virtual machine for 151 in the queue. So let's go to the queue and see 151. So the system is started just doing all of the experiments. So you can track your notifications from here, or we have another option which is sending notifications via email. In order to activate your email notifications, you must go to your user settings. So just click on your new username on top of the page, just down here, then you can see email notifications section in here. If any of the events have tick in front, which means Liquid Benchmark will send you an email whenever that event happens in the system. So for example, if you want to track your logins, you can have a tick. If you want to track virtual machine creation or anything like reading results or any other event, you can just put a tick in front and save. So anything happens, you will get an email. So basically I activated all of the events, so I will get emails in all of the events happens in the system. So I don't need to check all the time the notifications in Liquid Benchmark. I just go and come back whenever that event happens and I'm interested in that event. I just come back and check the results or whatever I need to do. So I just pause the video and will come back later. So now let's check the results. As we can see in here, the status is finished for all 3 of our attempts. In order to check the details of the results, we can click on details for every experiment. So we will get all the information like inputs, outputs from the for the results. I can try another one and we can see the outputs. The outputs might be different because each web service provides different outputs. However, we have time for all of them, so we can see time in this one, and for gzip we can still see time, and for XML ppm we can see time as well, so we can have a comparison between them. So now let's have a comparison. I want to compare all 3 experiments together. So I tick all 3 of them. I want to draw a chart. I draw a chart. I have to provide a chart type. So basically we have 3 chart types: time, column, and line. So I would like to choose line. So metric is time because metric is one of the output parameters. I want to use something which I can compare all of my experiments all together. So I choose time, click on OK, and I can see the comparison between execution time. I can see gzip has done it very quickly. I can go over gzip and I can see it's 156 milliseconds. So everything, if it's time, it's all of them are based on milliseconds. For xmil it took 375, and for XML ppm it took 4410. It's more than 4 seconds. So I can compare them. Also, I can get an image of this chart, or I can download the actual information in CSV format, or even I can get a PDF of it. So let's get an image. So I can save this image and I can use it. So I go to comment section here and I click on this button. Because there is no comment before, I can see it's blank and I can put a new comment. So it says write new comment here. So this experiment was really useful. And I hit on save. The comment has been saved and we can see the comment again, and this experiment was very useful. So the admin user, which was our account, our test account. So other users, if the experiment is public, can put a comment there. So we can basically have a kind of social conversation and social comments here, which other users can basically know the other different users' ideas about the experiments.